Okay, so we're still on worksheet 1. This is now page 2. And so I've created some problems to go along with this page. So we'll notice there's now 3 parts to our function. This is the left side. This is the actual function value, ordered pair. It'll be simply a point on the graph. And this is the right side. Now notice that this side is just y equals -2. So again, it's a horizontal ray, and I'm going to want to go left. Here's my left hand, so here is my left arrow. It doesn't have an equal sign, so it's an open circle. And the coordinates of the open circle, -2, -2. And so now I can come over here. This time I put in that magic line where we only want the left half of a horizontal line here that I've drawn. I don't want the whole line y equals -2, just its left half. We decided this was going to be -2, and so I'm going to go to the left, went a little above so you all could see it. This is the limit as I approach from the left, and from the left side we see it's just going to be -2. Now, when I come to look at this particular space right here, it's what I call the at, not the near. Remember, this is near and left, near and right, but this is exactly at. It's going to be your closed dot, and we have the ordered pair, -2, -3. So 1, 2, 3, there's my nice closed dot. It's a nice standalone little point. And so when I go to the third function, this is from the right. And again, it's a horizontal line, but since I only want the right side, it's a horizontal ray right. And the right side, so here's my right hand, right arrow. Again, it doesn't have the fact that it's closed, so it's open. And the coordinates are -2, 5, and it's open. And so up here is 4, 5. It's open, and I want to head right. So a little darker so you can see it. I can stop it here without an arrow, or I can put in the arrow. I could stop short anywhere along the line. But from the right, you will see that this is 5. Once again, these are not equal to each other. So I know that, again, I have another jump, and this is D and E. But look, the function value is all standalone right here. It's just the ordered pair, -2, 3. And so here's another form of the jump. Both of these were horizontal lines, left half, another horizontal line, but I only wanted the right half and a standalone point. So now, problem 5 is going to be one of these crazy ones where we're going to have to work with it and deal with what happens to us as we play the game. And so as I do this particular problem, what happens when the contents inside are negative? Well, you were told to take the opposite. So the absolute value of x minus 3 is the negation of x minus 3 over x minus 3. Well, that reduces, and I'm simply left with -1. And this occurs when x is less than 3, because 3 is what makes this 0. And when I'm less than 3, I'm going to be negative. Well, what do we do for an absolute value when we're positive? What you see is what you get. And so this is equal to 1. And again, I'm only positive when x is greater than 3. So what do we see that we've got? Once again, I'm going to see here that I'm going to have a horizontal ray left. And the coordinates are going to be 3, -1, and it's going to be an open circle. And so this is really just -1, and I get -1. I put in the magic line, and so I'm going to plot 3, -1, and I want to go left. And you say, I don't want to go all the way to the end. Then make sure you definitely do put an arrow. And then I want to do the right side. Oh, I forgot to put in the little left duplicate there for you. And then I want to do the right side. And what do I see? It's a horizontal ray to the right. The ordered pair is 3, 1. Again, it's open. And a horizontal ray to the right looks like this. And she was just rushing along. Sorry, guys. I forgot to draw my left one, but I think you ought to have horizontal down by now. And so I'm going to go to 3, 1. It's also an open circle. And this time I'm going to go all the way to the end, and so I don't have to put the arrow on if I don't choose. Your teacher usually does, because she was raised that it had to be an arrow, but some professors are now becoming sloppier with it. So on the right side, this is 1, so I get 1. Again, these numbers are not equal, but they are real, so it's a jump. This is D and E. But look, nowhere can I equal 3, because 3 is not in the domain. You get 0 over 0, so this sucker is undefined, and there is, in fact, no ordered pair for it. Problem 5 is going to be another one that's going to have 3 parts. You're going to see an oblique ray, an ordered pair, function value, point, and you're going to see another oblique ray. For the top one, it's positive slope, but I want the left side, so there's my left hand and left arrow. It's not equal to, and I know this is an oblique ray, left, -1, and then I plug in -1 and get -3 is going to be my open circle. So I can come over to the line, x equals -1, and I have -1, -3, and it's an open circle. Now you could go easily say -4 gives me -6, -5 gives me -7. Or the way I like it is slope, but that slope says I'm going up and right, and I want to go left. So I'm going to negate the top and bottom. So I'm going to go down 1, left 1. So down 1, left 1, down 1, left 1, down 1. See how I could just keep on going. I could stop at any point I want. But since that one was so sweet, I could just draw it. I don't need an arrow. I could put in an arrow. I could have just done 2 points, put in the arrow. Folks, doesn't matter. As I approach -1 from the left side, the function is x minus 2, and this gives me -3. Now, I'm going to do my ordered pair. This is simply some point, because it says x equals, and it means that encompasses exactly 1 point on your graph, not a line, not a segment, nothing. So I plug in -1, and I obtained 2, so it's close. So what is my function value down here? It's simply 2. I've already done it. And now I want to do the oblique ray on the bottom, which tells us that we're an oblique ray right. My endpoint would be -1, 2 plus 3 is 5. Again, it's an open circle. So I have -1, 3, 4, 5. It's an open circle. It has negative slope. I want the right side, so there's my arrow. So that's an open circle because there's no equal to there. You can put in another point. You could say 0 gives me 2, 1 gives me -1. Teacher doesn't care. She's going to do slope though. And since this says go right, the denominator needs to be positive. So I'm going to go down 3, right 1, down 3 more, right 1 more. I could go down 3 more. See, I could just keep doing it till I get to the end of my graph. If that makes you happy, just do 1 or 2 points and stop. You could stop and put your arrow right in here. Teacher doesn't care. But notice, what is the function right here? The function is 2 minus 3x. 2 plus 3 is 5. Again, these numbers are not equal to each other, but they are real numbers, so it's a jump, and this is D and E. And so now we have seen this algebraically, analytically. We've seen it graphically. I could look at the graph. Oh, from the left, it's approaching -3. From the right, it's approaching 5. Oh, wow, they're not connected. They're totally different numbers, D and E, a jump. Oh, the function value is 2. The only way, again, that you've not seen anything in this video, is numerically. And so endeth the examples for Piecewise 1, page 2.